5.4 Subtracting polynomials. When we subtract two polynomials, we write each polynomial in brackets. This one is exactly the same as adding two polynomials. For example, if we want to subtract these two polynomials, we use the pair of brackets for each polynomial to show I have two polynomials in this subtraction. But subtracting polynomials is more difficult than adding polynomials. Let's look at the first example. Use algebra tiles to subtract polynomials. We have two polynomials. The first one is 5x plus 3. The second one is 3x minus 2. The first step is we only need to sketch the algebra tiles for the first polynomial, 5x plus 3. 5x plus 3 means I have positive 5x. I need to drag 5 yellow rods. Positive 3 means I need to drag 3 yellow little squares. Minus 3x minus 2. That means I need to take away 3x minus 2 from those algebra tiles. The first term in the second polynomial, 3x, that means I need to take away 3 yellow rods. So those 3 yellow rods are gone. Take away negative 2. I should take away 2 little red squares. However, there's no little red squares. If I want to take away 2 little red squares, I need to put the 0 pairs. So 1 yellow, 1 red. 1 yellow, 1 red. These two pairs are 0 pairs. They are zeros. So it doesn't affect this algebra tile result. However, after you add 2 0 pairs, I have 2 little red squares that I can take away. So after I take away the second polynomial from the first polynomial, let's look at the result for the subtraction is these 2 yellow rods means I have 2x. Then I have 5 yellow little squares left. This one means plus 5. So if I use the algebra tiles, I can get this one minus this one is 2x plus 5. Let's look at how we can subtract these two polynomials symbolically. Like adding two polynomials, we still have two different methods. One is a horizontal method, the other one is a vertical method. For the subtraction, I would like to start with the vertical method. Like adding polynomials, when you put on two polynomials in a vertical format, you need to align the like terms. 5x plus 3, you put on in the first row. So the second polynomial, 3x minus 2. So for 3x, you need to put it under 5x. Negative 2, it's a constant term. You need to put on this term under positive 3. So this time, I have two columns. For these two columns, I need to do subtraction in each column. 5x, take away 3x. 5, take away 3. This one is 2x. Positive 3, take away negative 2. Positive 3, take away negative 2. In Unit 3, we talk about how we can subtract two integers. When we subtract two integers, we change it to the adding and opposite the second number. So the second number, negative 2, becomes positive 2. So this one is actually positive 3 plus positive 2. This one becomes positive 5. So positive 3 take away negative 2 is 2x plus 5. So this result is the same as what we got from the algebra tiles. So let's look at how we can minus these two polynomials horizontally. The first one is 5x plus 3. I just remove the brackets right away since it's a positive sign in front. However, this one is the subtraction. When you remove the second pair of brackets after the subtraction, we need to change the signs. Why do we need to change the sign? I take this minus bracket 3x minus 2 as -1. So I will do -1 times 3 become -3x. -1 times -2. -1 times -2. Negative times negative become positive. So this is the difficult point of subtracting two polynomials. When you remove the second pair of brackets, you need to change the sign for the second polynomial. So it's minus 3x, negative become positive 2. So right now, I only need to group the like terms. 5x was negative 3x. They are the like terms. Positive 3 was positive 2. They are the like terms. So 5x was negative 3x. Yellow was yellow. Become 2x. Blue was blue. Positive 3 plus positive 2. Oh, that's the reason why we still can get plus 5 in this way. Okay, let's try to minus these two polynomials. I think probably the vertical method works way better than the horizontal method. So we can start with the vertical method. So I copy down the first polynomial, then subtract the second polynomial. When I write on the second polynomial, make sure you can align the like terms. The first term, negative a squared. I put a negative a squared under negative 2a squared. The next one is negative 3a. I put on this one below plus a. Plus 2. For this term, this one does not have variable a. So this one is the like term with -1. So I put on positive 2 below -1. Now let's subtract in each column. When you want to subtract in each column, you only need to subtract their coefficients. Let's look at -2 take away -1. What is -2 take away -1? Let's recall what we learned in Unit 3. When you subtract two integers, you change the minus to adding and the opposite the second number. So -2 plus +1. This one is -1. So right now, I know I have -1a squared for the first column. -1a squared is the same as -a squared. The second column, positive a take away -3a. We all know this one. Positive a means I have positive 1a. Positive 1 take away -3. What we can do is I change the minus to adding and opposite the second number. So positive 1 take away -3 become positive 4. So the second column I will get positive 4a. The last column, -1 take away positive 2. -1 minus positive 2. When I minus them, I change the minus to plus. And the opposite, the second number. -1 plus -2. I lost $1. I continue to lose $2. So I lost $3 in total. This is the reason why we can get -3. So this one is -3. -a squared plus 4a minus 3 is the subtraction result. How can we use the horizontal method to subtract these two polynomials? Horizontal method, the first pair of brackets, I did not see any sign in front of this pair of brackets. That means this one is positive sign. Then you can remove the brackets safely since you only have the positive sign in front. So keep the first polynomial after you remove the brackets. But the second one, since this one is a minus, I take this one as a -1. -1 times -1, negative times negative, this one become plus a squared. -1 times -3, this one becomes positive 3a. -1 times positive 2, negative times positive becomes negative. So this is the challenging part in subtracting two polynomials. But if you use the distributive property to help you understand, I think it should be okay. Okay, so right now I group the like terms using the highlighter. -2a squared with positive a squared. Positive a was positive 3a. -1 with -2. Combine the like terms by adding the coefficients up. -2 with positive 1a squared. Both of them are in yellow colors, so I will get -a squared. -2 plus 1, -1a squared. Positive a plus 3a. Positive 1a plus 3a becomes positive 4a. Blue with the blue color. -1 minus 2. It's -3. So we can get the same result. Right now, I want to check my solution. How can I check my solution? If I go back to the first one, here, there is a hint for you. Check your solution. Add the difference to the second polynomial. Then you should get the first polynomial in the subtraction. For example, this is the difference. I add this difference to the second polynomial. So 2x plus 5, add this difference to the second polynomial, 3x minus 2. We know how to add two polynomials. As long as you align the like terms, you only need to add the coefficients up. Positive 2 plus positive 3, positive 5x. Or we can just say 5x simply. Positive 5 plus -2, positive 3, which is the same as the first polynomial in the subtraction. So that means my difference is correct. So here, if you want to check if my difference is correct, I will use the same method. I will add this difference to the second polynomial. Look at the second polynomial in the second pair of brackets. It's -a squared minus 3a plus 2. Add them up. So you only need to add the coefficients of the like terms in each column. -1 plus -1, -2a squared. Positive 4a plus negative 3a. Positive 4 plus negative 3. Positive 1a. Negative 3 plus positive 2. Negative 1. Look at this one is exactly the same as the first polynomial. So this one suggests my difference is correct. Let's find the difference for each polynomial expression and check your solution by adding the difference to the second polynomial. If you don't like the horizontal method, you guys can stick to the vertical method. So here I will use the vertical method to demonstrate the subtraction. Negative 3w minus 12. Take away the second polynomial, negative 9w. Align the like terms, w with w. Minus 6. Both of these two numbers without any variables. They are like terms. So, right now, I only need to minus the coefficients in each column. Negative 3 minus negative 9. Follow what we did in the first two examples. I change minus to adding an opposite to the second number. So negative 3 plus positive 9 becomes positive 6. So this one is positive 6w. The second one is negative 12 minus negative 6. Change this minus to plus, opposite to the second number. Negative 12 plus positive 6. This one is negative 6. So I got to this one, minus 6. So the difference for these two polynomials is positive 6w. I can ignore the positive sign. It's just 6w minus 6. Let's check my solution here. If I want to check this solution, I add this difference to my second polynomial and look at if I can get to the first polynomial. Positive 6 plus negative 9, it's negative 3w. Negative 6 plus negative 6, it's negative 12. It's exactly the same as the first polynomial in the subtraction. So that means my difference is correct. So right now, let's use the vertical method to minus these two polynomials. Copy down the first one. Put on the subtraction symbol here and write on the second polynomial. When you write on the second polynomial, make sure you can align the like terms. The first term 2n squared, I should put this term below negative 3n squared. The second term, negative 4n, goes with positive 9n. Plus 13, positive 13 should be under positive 7. So right now, I only need to subtract the coefficients in each column. Negative 3 minus 2, it's negative 5n squared. If you still have trouble in subtracting two integers, you can put all the work aside here and change the subtraction to plus and opposite to the second number to look at if you can get a negative 5n squared. Positive 9, take away negative 4. Change this one to plus, opposite to the second number. So this one becomes positive 13n. Positive 7 minus positive 13. Positive 7 minus positive 13, change this one to plus and opposite to the second number. Positive 7 plus negative 13, it's negative 6. So the difference for this one is negative 5n squared plus 13n minus 6. How can I check my solution? I will add this difference to the second polynomial to look at if I can get to the first polynomial. Negative 5 plus 2, negative 3n squared. Positive 13 plus negative 4 plus 9n. Negative 6 plus positive 13 plus 7. This green one is exactly the same as the first polynomial. So that means my difference is correct. Okay, so let's try the last one using the vertical method. Let's write down the first polynomial always. Then minus the second polynomial. When we write out the second polynomial, make sure you can align the like terms. Negative 5g, that's the first term in the second polynomial. Negative 5g is the like term with positive 2g. So I put this one and positive 2g. Positive 10 is the like term with negative 14. So I put on positive 10 and negative 14. Negative 7g squared should line up with positive 3g squared. Negative 7g squared. So right now, I only need to subtract the coefficients in each column. Negative 14 minus positive 10. Negative 14 minus positive 10. Change this minus to plus and opposite the second number. Negative 14 plus negative 10. Negative 24. Positive 3 minus negative 7. Positive 3 minus negative 7. I change the minus to adding and opposite the second number. So this will become 10. So plus 10g squared. So the same one for the last two like terms. Positive 2 minus negative 5. Positive 2 plus positive 5 plus 7g. So the difference is negative 24 plus 10g squared plus 7g. But in most cases, we prefer the polynomial in descending order. So I will write down this polynomial as 10g squared plus 7g minus 24. How can I check my solution? This one is my difference. I add the difference to the second polynomial. Okay, when you add them up, make sure you can line up the like terms again. So negative 5g, positive 10, negative 7g squared. So 10 plus negative 7, 3g squared. Positive 7 plus negative 5 plus 2g. Negative 24 plus positive 10. Negative 14. This one is exactly the same as the first polynomial, although they are in different orders. However, the terms are exactly the same accordingly. So let's look at example 4. Which polynomial must be subtracted from 5w squared plus 3w minus 2 to get negative 7w squared plus 5w plus 1? So this one is the difference. So I need to subtract one polynomial from this one. So this one is the first polynomial. Subtract which one I can get negative 7w squared plus 5w plus 1. Okay, Let's look for the second polynomial. How can we find the second polynomial? If we know the first polynomial and the difference, we can use 5w squared minus this difference. 5 minus negative 7. So this one is 12w squared. Okay. So the second polynomial starts with 12w squared. Positive 3 minus positive 5 minus 2w. Negative 2 minus positive 1. It's minus 3. So if you guys don't believe this blue answer, you can double check with the subtraction again. 5 minus 12. Is that one negative 7w squared? Positive 3 minus negative 2. Positive 5w. Negative 2 minus negative 3 becomes positive 1. So the polynomial we are looking for is the blue one. Let's look at the last example. It's a problem-solving question. The parameter for the rectangle is 12t plus 28. Determine each unknown length. So in 5.3, we tried to add all sides up in order to find the parameter of the rectangle. So this time we know the parameter. That means if you add all 4 sides up, the result is this one. We know this side is the same as this side, so this one is also 4t plus 6. How can we look for these two sides? So what I will do is, this time I do subtraction because I don't know these two sides. I'm looking for these two sides. If I subtract these two sides from this one, the difference should be these two sides. Or we can see the sum of these two sides. So I subtract the first 4t plus 6 from the parameter. 12 minus 4, 8t. 28 minus positive 6, 22. Continue to minus the other side, which is 4t plus 6, this opposite side. 8t minus 4t, that's 4t. Plus 22 minus positive 6, 16. So 4t plus 16 is the sum for these two sides. And these two sides are equal. Although we don't know how to divide 4t plus 16 by 2, we can say I want to split 4t equally. If I want to split 4t equally, let's just say we can split 4 apples equally. So each side has 2 apples. The same idea to split positive 16 equally. Positive 16 divided by 2, this one is easy, so we know this one is plus 8, this one is also plus 8. So right now I know this side is 2t plus 8. This side is also 2t plus 8.